Hello, everyone, again. Let's start. I'm glad to see all of you at our webinar. My name is Andrei, and I'm VP of Sales in ABM Cloud. Today, I will moderate this webinar. Before we start, I want to talk about a few organizational moments. Who we are. We are specialists in supply chain management, and our mission is to deliver innovations to business. We have already helped more than 100 companies to achieve their key performance indicators in supply chain management with our experience and our software. Our clients are mainly distributors, manufacturers, and retailers. And these are from different fields of business. Today, our main speaker is our Chief Executive Officer, Sviatoslav Oliinyk. He is also a demand-driven Institute Master Instructor. About your questions on this webinar, you will have opportunity to ask questions aloud if you raise your hand in Zoom, and we will turn on your microphone. Or you can also ask your questions in chat during the speech. At the end of the webinar, we will give answers for all of your questions. I wish you to get information you can use with or without us. Good luck. Sviatoslav, can you show your presentation, please?
Yes, thank you, Andrei. Yes, I will. Just 1 second. Yep, I will demonstrate my screen. Okay.
Yeah, your presentation on the screen. You can start.
Can you see it, right? So, really should just to get to know each other, right? So, could you write please in the chat from which industry are you in, so I could know where to focus, like FMCG or etc. Right? Here's the QR code for my LinkedIn. Just if you want to stay connected and get some latest insights about the supply chain, etc., and DDMRP methodology. And the mission of our company is to make innovations available for the business, right? So not only like some theories and you do not know how to apply them, but real practical solutions that you can get the benefits right away, right? So this presentation, it's more about like practice, tools, and approach. I will make some short review about the methodology, just to get the basic understanding of why we need other tools and methods, yeah, right? What basically changed and how could we apply this? So, and then I will show some tools of how they actually look like, so you could understand how to apply them, right? So, what is the most spread and most known basic supply chain approaches? You could basically split them on two camps, I would say, yeah, like push and the pull. So what is the difference between push and pull? Basically, push are commonly called such as order point or MRP approaches. Actually, to give a short historical intro, order point was the most spread and common supply chain approach before MRP. MRP became popular when the availability of computers became when the computers became very available, yeah, to the companies. So what is the logic behind order point? Actually, the logic is quite straightforward, and that's why it was the most popular approach, like before 60 or even 70s. Actually, some companies still using it. So just make it more sophisticated algorithm of calculations. But guys, the logic is quite straightforward. If you have, for example, forecast for your next year, yeah, annual forecast, and you know what of the amount is going to be sell. You know the cost of the good, you know the risk of out of stock, the forecast accuracy, the holding costs, right? The more inventory you hold, it's more costly, it takes space. Also, it's getting like spoiled with the time, right? So its value decreases. So, and there are, actually just on the internet available a lot of different, more sophisticated calculators. But the key idea is that you are finding like two curves when making orders is becoming more expensive, and the more you hold inventory, the less income you get, right? And on that point in the middle, you got the optimal point, like economic order quantity, right? So the best order amount to order, right? Order size. So if you get the ideal order, all in the next one we need to get is the safety stock. So you have again the same logic, and you just calculate basically the safety stock and the order point, and you put inventories in some places. So what is the main benefits of this approach? Obviously, guys, it's really, you can calculate it, you can see the formulas. It's hard to put some other opinions if you have like direct actually formulas. You know what you have to do. But actually the trick is that the more volatile environment becomes, the more bill of materials, the more new SKU come, the more often you need to recalculate. For example, I had some raw materials that I used to produce 5 components, but in 3 months I'm gonna produce not 5 but 7 of them, and in 6 months even more, and one component is not selling anymore as I expected. So I just produced the first batch and it just lying on our warehouse and we are not using it. So the more unique BOMs and SKU you have, the shorten the product life cycles, the most frequent you have to recalculate it. And actually, because lack of this connection with the whole system, that's why MRP became the #1, because the logic behind MRP is called dependent planning. It's actually really straightforward. If you have the forecast, then you can build the production plan. If when you know on which day, which line, which working center, the exact amount that you are planning to produce to cover this expected sales, then because you have the current inventory levels, VIP, you have the bill of material. So basically you can calculate material requirement, how much actually you need this to to fulfill the production, right? How much materials you need, and you know the dates. Again, the same logic. When you know how much of the current inventories you have, what goods in the transit, when you're gonna use in production, you can simply order the materials, and that is the strongest point of MRP. It treats the whole supply chain as the one dependent. So it's very good and convenient, especially for the top management or the mid management, to basically manage the whole system. Because if you just change or tweak the one number, the forecast, so the production plan will change and the ordering of materials will change. So anytime you change this one number, the whole system adapts. So it gives you a really easy and convenient tool to manage the whole system. The problem is, every time just you change this number, every time you change the forecast, this whole bullwhip effect, right? These fluctuations, they are going through the system, and they, just today they were stolen, for example, for the planner, hey, you need to build 1,000 units of product A. They changed the forecast, and the same minute, he say, forgot about product A, you have too much of it, now you have to build product C. And in order to make some sort of stability in production, usually this approach use the frozen horizon, right, guys? So that's why we calculate forecast on a monthly basis, We do the production planning on a monthly or weekly basis, just to get this sort of stability. Yeah, usually we do some workarounds in the spreadsheets and just changing, tweaking those numbers, but actually it's happening quite rare, and we are trying to minimize this. Yeah, we're just trying to stick to the plan. And most of the companies, they even have the metrics. What is the percentage of the plans that you actually build, right? and it's actually quite strange, because if we really know that the plan that we have for the next month is wrong, and it's 100% is wrong because we don't know the actual sales, some of the suppliers could be late or etc. But we are still measuring how well we did that plan, what the percentage we actually built. That's why, because of these frozen horizons and over relying on the forecast, it's end up that a lot of companies was creating a huge volumes of the finished goods and resources to cover all those volatility, right? And it's lead that the company was actually having too much of the inventory that they do not need, and too little of inventory that they actually need. It's called like bimodal inventory distribution. So again, is to sum up, this approach, MRP, is why it's called push, because they really rely on the forecast accuracy. So they look some time ahead, build the forecast, build the plan, and then executing the plan. The problem is on operational level, because the plan and the reality usually is different. And the conflict between what was planned and what actually has happened leads a lot of workarounds, expedites, and extra work that actually ruin the whole idea of the stability and effectiveness that is claimed, right, when you basically build this plan at the beginning. So that leads that the new approaches became very popular, like Lean and TOS. Again, guys, Lean is the whole methodology as well as TOC. I'm not here to discuss the whole methodology. Actually, Lean is one of the best approaches if you wanna get the exact and specific instruments how to make your operational environment and working centers more effective, how to decrease time of, for example, single minute exchange of dice, right? They have this 5S, 6S, etc. I will speak here only about how you manage inventory, right? How do you decide how much you and when you have to order? So the logic between all those methods, they are quite different, but basically they are a lot of the same, right? I will speak on the key differences. So the logic between Lean is you need to map the flow, right? When you map all the flow and all the working centers, when you put the Kanbans between all the working centers, and you trying to balance the flow. So the whole idea is that your flow has to be balanced, and each of the segments are not building anything before the next one actually needs something. So it's actually quite interesting, guys, because the real inventory management is working on the operational level. So basically, the guy at the working center, if he needs some material, he's putting the Kanban and he's managing all this inventory. So the actual demand triggers actual production triggers actual consumption that goes to the next working station and to the next one and to the next one. Seems great, right? We have balanced chain. What can go wrong? And the problem is the market. Why? Because if you are quite effective and stable in the operational environment, and your fluctuations in the operations are quite small, and you actually build what you want, yeah, the balanced flow, the problem is that the market still could decide not to buy anything from you tomorrow and buy like monthly amount next day, right? So at one day, again, because you have this Kanbans, you get some stability, seemed some stability when there is no market fluctuations. But when we get real high market fluctuation, you have no buffer that could dampen that variability. And that variability is directly transferred to the shop floor. So if you connect all your Kanbans to the real market demand unstable, you will end up with the real fluctuation at the production level, because you always will have some rush moments, then not enough of the workload, etc. So this is one of the weakest points, that when you're making the system lean with nothing excess, right, that with little or no margin for error, or to handle the volatilities that come in both ways on our system, either from suppliers or from the market. So you actually those supply chains becomes quite fragile, and a lot of companies that actually implement lean, they say, okay, we will use lean to be more efficient, to make faster setups, to make order on our operational environment, our production centers, but we will still use MRP in planning. This is one of the most common approaches, because even though we know this is ineffective at the operational level, but at least we know how to manage our system. At least the management have some leverages to direct and to operate the system. Here they don't. Yes, they can recalculate the Kanbans and the takt time, etc. But they're losing this leverage as at least in this visual and easy form that they have in the MRP world. So TOS is also the pool method, but it has a bit different approach. They say this probably not the best idea is to have this balanced flow, because if the one of the working centers breaks or something happens, the whole system will stop. So we should find the most like bottleneck, the weakest link inside our flow, and we should manage and operate by looking at this weak point. And this is the key point, because when we are managing the bottleneck, we are managing the result of the whole system. And the buffer are calculated very easy. Actually, it doesn't matter how do you calculate the TOC buffer. Usually they take time between orders and the lead time. So, and you just for example, if I can order once per week and the lead time is 7 days, so we just took like 14 days, multiple by average daily usage, how much in the day we're using, and we could get some, I know, like 20% Murphy, or that we usually add, like, to cover some volatility. And each of the consultant has their own, like, practice. It doesn't actually matter, but the real trick is that it doesn't actually matter how you calculate this first one buffer, because the exact inventory management is called dynamic buffer management. The tool is called algorithm. So basically what it does, when you build the buffer, it has 3 zones by 33% each of them, red, yellow, and green. And the system is frozen by those horizons, fixed, yeah. And then when we look at this previous horizon, right, like for example, this previous lead time, and we just look in where our inventory level was. If it was in red, then our buffer become bigger, plus 33%. If our inventory was in the green, then our buffer becomes 33% less. This is called dynamic buffer management. What is the obvious strength? Is probably the most simple approach there is. So when your consumptions go back or down, or your buffer will flex up and down. So it's very easy to adjust. The problem is it's all about reflecting the past dynamics, right? So if the past you have this kind of inventory levels, it doesn't mean that the next one is going to be the same. So the pool methods, the core strength, all of them, they are really focused on the efficiency of the operational environment. And probably the weakness is that they are lacking the effective and very easy and useful management tools of how to guide or where to put your system, right? So they are basically reacting. So again, guys, if to sum up, all the tools that are in the market, most of them basically are just based on some methodology, because tool is just codified some algorithm. So if you use push or pull methods, you should be aware of the strengths and weaknesses, because not because of some type of the software, etc. It's because the tool itself, the logic of this of the methodology at the core itself. So the first one, if we rely on the forecast accuracy and we require perfection, we require this. Those guys require perfect world. We need to know exactly how much we're gonna sell. We need to have our working centers working exact time, no lates, no early, no breakdowns, to be as perfect as it could be. But everyone who had real life experience knows that it's not never the case. You never have the lead time in production like 5 days. You could say it's lead time in average. Sometimes it could be lead in 4 days, sometimes in 7. Depends of a lot of different stuff. That's why it's very effective and easy on the management level, at the S&OP level, right? You have the tools to manage it. The problem is that they're losing this effectiveness on the operational level. Those guys are quite vice versa. They are quite effective at the operation level, but they lacking the skills and tools for the management to be on the that level. So guys, why just we couldn't connect them? The problem is they could not be connected. There is no bridge, right, with them. So there is new method. It's called DDMRP, and it's all about flow. It's to say just in a few words. So it has the strengths of the push approaches. In which sense? We can use also the forecast to adjust, to guide our system, but we will not use the forecast to build orders as a use in the push approach. So we can use the forecast to adjust our system, but we will actually build what is the current orders to what is the current actual demand. And so the main questions why I assume most of us are here. So how high a service level could be achieved with the lower inventory levels? Because in the MRP world, one of the easiest answers is, make a better forecast. That's why you can have less safety stock. But we know that the world is becoming more dynamic, unpredictable, fast changing. So it's more complex. It's getting harder and harder to give this demand. So how can we do it? So there's a lot of tools in the DDMRP. I just want to show you the implementation of the first one, the principle where we should hold our inventory. I'm just gonna show you the system. Okay, so if you look at the workbench, let me choose just some SKU. For example, we have, guys, second, I'm gonna stop demonstration and restart it. 1 second. Can you see my screen? Can you see the system?
It's okay, Svet. Yeah.
Okay, great. So if you look at for example, some finished product A at the plant. Now, guys, we're gonna speak this example with the finished product A. I just want to show you example on the production side, right? So if you look at the finished product A at the plant, right, there is some properties, just usual SKU card, right? What is the name of the plant? Is it finished or raw material? What is material cost? Who is responsible? Are we producing or buying it? What is average daily usage, lead time, minimum, maximum, etc., etc. So any just basic information we need to have some general information what the part is, right? And the system, having all this information, it calculates the buffer. So if you have in such a long lead time, such level of consumption with your forecast, this is the buffer is calculated red, yellow, and green on the DDMRP methodology. I'm not here to get all the details, but I want to focus you on the one interesting stuff. So, for example, this is the setup, if we're gonna work on during the DDMRP buffer, we're gonna have an average 85.5 units. Let's just round out 85 units, right? And we know that each unit costs $1,000. So if we are planning to give the reliable output to our clients and give high service level, we need to put on our inventory 85 units, right? Still it's a lot. But because we're in production, there is such thing as a bill of material. And this finished product A, we need 35 days to build it. Why? Remember this from the lean 5 whys. Why we need 35 days? So the last operation is only 10 days, as you see. My mesh is gonna zoom up a little bit. So the last operation is just 10 days, but we need 35. Why 35? If you look, this here's the legend. It means that FPA, finished product A, is buffered. If you see this buffer here, the gray means it's not buffered. So we do not hold inventories there. We just build it and pass to the next station. We are not holding any inventories there. But if we expand all, you will see this is the really big bill of material. In some companies are even bigger, and it's just one SKU. But look what the system goes. And maybe you know this from the project management. There is tasks in the project management that has to be done in a sequence, and some of them that can be like parallel, right? So the system calculates the longest lag in a bill of material, and it gives you a good target to investigate. So for example, if I want to have shorten lead time, be faster, have less inventory, be more effective, and if I put inventory somewhere here or here, I will probably just waste some money. I will get no effect. So the best way to increase your efficiency probably is to put inventories on this purchase product A, PPA. So we know that here, if you, again, guys, if you go to the buffer sizing, in this current configuration, how the company was working, yeah, we just see how they could work on the DDMRP, and we see that they have like 85 units in average, and 1 unit is 1,000. So we understand that here we have $85,000 on average in materials, and we should investigate PPA. Okay, let's investigate this purchase product A. If you open it, we have also the same properties, and we see inventory method non-buffered. We are not holding it, so we are basically ordering from our supplier. He delivers it, and we send it to production directly. 25 days is the lead time, average daily usage, or the minimum, etc. So in this configuration, this is the purchasing planner is responsible, Joe, and the $100 is 1 unit cost, right? Much cheaper than the finished goods, because it's just only a small part of it. And there is no buffer, right? Because it is non-buffered. So we are not having any stock on, and we are not holding any materials there. But if you press edit, and instead of non-buffered, I will choose some buffer. What is this B22? It means that kind of, I would say, kind of profiles. Those profiles means like inventory management strategies. If, for example, if I choose B22, it means, and I pressed save, it means that it has like average lead time and average volatility. Just say like our, let's say, average purchasing material, for example. Not the stablest one, not most crazy one, just strategy for the average. So what system does? It's calculated the buffer itself, and it says, hey, you need to put 57.5 units on average to your inventories. And we know that 1 unit costs $100. So could you imagine the situation that you're going to finance director and say, hey, I have a great idea. I just want to put $6,000 if you round it up, right? $6,000 just on our inventories, plus take some space and take money and put money on the warehouse. I assume he would not be really happy, right, because of it. But again, system recalculates all, and because it sees all dependencies through the bill of material, and it looks where do you have or have not inventories before. So if you look at the finished product now, we look at the properties, raw material cost doesn't change now. But now if you look at the bill of material and we're gonna expand it, you see this purchase product A now it has this buffer sign. Why? Because I just put $6,000 on that point. But look what happened with the lead time for the finished good. Now I need only 14 days instead of 35 to actually build that finished good. So I save a lot of time. And what is really interesting, if now I am faster, it means that I need less inventory. Because the faster I am, the faster I can build up and react on the market fluctuations, right? So I don't need 85 units. Now I need only 41. So I just save 44 units, and one costs $1,000. So basically, with this operation, I just save 44,000 minus 6, because 6 I put in this operation. So with this kind of scenario, if I go, for example, to my financial director and say, hey, I want to take $6,000, invest in the purchase material to save in total around $38,000. So you get like 6 times more than you invest here. Sounds like a good investment, right? Because always there was, focus from the history before the, all those effective approaches before the actually the management accounting, the inventories was how they reflected in the balance sheet, right? As active, right? As your asset. So as your asset, it means good. The more assets you have, the richer the company. It was before the management account. On the management account, you say, okay, the less inventory I have, the more I sell, the better I do. So I need to take less inventories, right? So, and actually inventories is not good or bad. It's an asset, and it's supposed to be treated as asset. So it has to generate return on investment. So if we are investing some materials, we need to get some return. We need to be effective, right? So this is the good example how not improving any forecast or doing some faster change of dice, etc., by just reviewing how our operational environment is built, we can get huge results. And this is just, I know there is, guys, it's just an example in the production, right? But what if we have not only production and just kind of simple example? What if the example is a bit more complicated? For example, we have a few layers of the distribution network. For example, we have finished product E, some product, just to make it smaller. This is our central warehouse called plant, and it is delivered from the vendor. And the plant feeds 5 regions. Yeah, so the second layer of our distribution is the whole 5 regions. And the region 1 is the central, is the biggest one. It has also 5 local warehouses, for example. So one SKU, it has this one, 11 warehouses in total, like central, regional, and the end points, for example. This could be any combination there is. So usually, guys, when we are starting the project and we just quantify or make, like, say, digital twin, when we just reflect the current supply chain here in the system, as you see the results. Some SKU are yellow, so quite good, or green. Some of them are critical, so really bad situation, high and critical. And we have blue, which means excess inventories. What does it mean in practice? Some of the SKU are too little, some of them are actually too much of inventories. And also we can do, I'm not just planning to look at each SKU, but if you go to report section, and I'm not gonna show all reports. We have the report constructor, we have standard reports, we can build any report from the data that we have. But the idea is just a short reflection of this workbench. We have the plant, region 1, 2, 3, 4, and the warehouses, and it's just colored by the status. And we see blue is excess inventories, red is not enough. And we see that currently company has $567,000 on inventory, and having excess and having too much and too little. But if we start working with the DDMRP with the current configuration, we can reach high service level with only $412,000, which is already 25% reduction. So without changing any layout, just from switching from current methodology to DDMRP, we can get 25% less inventory. But plus automate the planning, move from the spreadsheets, etc. But what if we, for example, look for any, let's say, the most problem one, let's say at the warehouse number 4, and just look inside what actually is happening, right? So I can easily access to any of the warehouses I want to see, and I just want to look at this one. If we see this guy's bill of material, right? It doesn't mean it's called the bill of material, but it actually also means our distribution line. For example, yeah, we know that FPE is we are not producing, we're just on the distributors, and we see that on plant it's just we are buying from the supplier. This is the second line, regional warehouses. This is end warehouses, warehouse 4, right? End location. And we know that we need 36 days. If we order something today, we will receive it after 36 days. Why? Because we need to wait 30 days when it comes to the central warehouse, 3 days to the regional, and 3 days to the endpoint. And system says, okay, try to hold here or here. So anyone, this is like the longest leg. So let's do again the same. Let's look if we, for example, the plant, the central warehouse, look over buffer sizing, see we haven't, so we just working as the cross docking, right? We just ordering, it's come to this warehouse and just splitting on the distribution. And we think that we are very effective, right? We are not wasting any materials on the warehouse, etc. But what if we do the opposite? What if we try to be less effective, right? And choose the same, I don't know, B22, it means I am buying this material, right? Medium lead time, medium variability, etc. Just usual SKU. And the system is recalculating. And after this recalculating, I can see the buffer side. It calculated the buffer, and I know that I put some money there. But I don't have to actually, again, do these calculations, but obviously we can. I mean, the easiest way, I'm just gonna copy this report and open it in a new tab. It shows, because it's the browser, it's very easy to open the same report in few ways. I didn't update that page. So here, this report, and this report is already updated, right? So what is the difference? On the first one, we basically can compare the models of the distribution network. In this model, it's enough to have only $411,000 to be effective, not changing the distribution layout. So we get like 25% less inventory. But if we reconsider how our distribution model looks like, and in the demand-driven planner, there is few layers, few ways how to do this in detail. So if you haven't been in the course yet, I highly recommend the demand-driven planner course. Let's give you the idea of how to do this. What is the idea behind it? What is the logic behind it? Obviously, the tool can help you with the calculation, but you can do easily even the spreadsheets after the class. So again, why this is happening? Because now that we decide to hold inventory at the central warehouse, right? So the lead time for the end locations becomes shorter. And now we don't need to wait all those long horizons. And now we can give the same service level to our customers with almost 40% less inventory, 40% less inventory. If you go at the workbench, and again, look at remember our warehouse 4 was the most problem one. Let's open this warehouse 4 and look at the bill of material. As you see, expand all, we see now that we need to wait 6 days before we receive, because now on the central warehouse, we have inventories, and we can see what situation would be if we will not hold inventory there, what situation if we will hold inventory there. Again, in the real life, it's just like this, but a bit more complicated. For example, we should make the same report, but only look, for example, on in total, not only in money, but let's say in pallets. Maybe, for example, the central location just has not enough space. And for example, if I have only 100 SKU on our central warehouse, if I buffer them all, I cannot. I have like, I would say 50%, 50 SKU I can hold, 50 not. How to decide, right? Is it ABC, Z analysis? What is the logic behind? And the demand-driven approach and methodology gives the clear answer of how to choose which SKU should be buffered to give the maximum service with and reliability with really low inventory levels. Guys, so this was really a simple example. I not was looking even at the buffer calculation and how should I approve orders and delete orders, etc. So it's just the idea, guys, to show where to hold inventory is extremely important, because we can get the real double digits effect with only changing the layout of the production or of the distribution. The next one, guys, this is the example a bit of the methodology itself. Remember the first slide of my presentation, we were speaking about the differences between push and pull approach. So the push, the most negative effect from the push approach, one second, let me, yep, pen, yep. So the most negative from the push approach is that it's one-way street. You get from the S&OP, I don't know, okay, I'm not good, S&OP. You're moving from the S&OP down to the operational level, and it's basically the one-way street. Of course, that in this process there is some small loops of the feedback when you see, okay, I have this plan, will I have the capacity, will I have the finance, will I have, okay, and after all those small loops, when you just justify this S&OP, the whole this holy grail of the system and with exact number, okay, this is our forecast, this is our production plan, and you just got like one-way street, and this line is gonna be like live, right, until the next S&OP come, right, and then they have another line, etc. So it's basically one-way street with that what at one point you just destroy everything and recalculate. But why? Because the longer this lag is, the longer the frozen horizon, the bigger the gap between planned and actual becomes, right? This length, and then reappeared again. So in order to mitigate this, there is pull approaches we discussed. The problem is you're losing this tool, you're losing this ease of managing, of directing the whole system. So in that way, methodology DDMRP evolved with a different approach. It's done with the logic of managing the complex and adaptive systems. You have two layers, the tactical, sales and operations, and the operational range. Operationals are two different sides. Managing materials, we just briefly touched it. When you're just managing replenishment of the inventories, defining the levels of inventories you're gonna have, how much to order and when, and the execution. If you have the order, is it executed correctly? Is it done too early, too late? So here we are talking about inventory buffers, and here is the time and capacity buffers, right? So I just want to show you the whole how the S&OP looks like again in the system. I hope you're gonna see it here. So how actually it does look. So in DDMRP, yes, we are doing what actually market wants, but it doesn't mean that we have no planning ahead. Obviously we do. And for example, projected supply, we also can take this, annual forecast and convert it. For example, if this is finished good, B24, for a production plan for the whole year, we're gonna build 112,000 units, and this is, you see, by the weekend, by the weeks, and you can see the projection, how the projection looks like. This black line is the level of inventory, how it's gonna look from each SKU, what is the level of this inventory, and etc. So you could get all this levels. So but if it, the buffer size and etc. But if it's not the finished good, but if it's just purchase material, the same way, you can actually even share this information with your supplier and say, hey, for the next year, this is how I am planning to order, but I will order not as it is in the system, but on my actual needs. If the market consumption change, I will order different other amount. But this is very good to to have you a good estimate of what actually how much you're gonna build, how much you're gonna order. Obviously, if you have projected supply, you can project inventory levels, what was the average inventory in the units. It's very easy to convert units to cubic meters, pallets, tons, dollars, etc. So if you want to reach some type of the limitations that you could face, right? For example, again, and rough cut capacity. So the whole idea, guys, of this one is not to build and to give the task for each machine like 1 year ahead. So this minute you build this one, the next day you build this one, etc. No, it's just builds. Yep, it just builds the graph of. Obviously, it's Friday, so we don't have a lot of working hours left, right? But the next day we have more hours, and etc. etc. So we can see different, like 12 months, 28 days, etc. Every view that we are interested in. But guys, the trick here is that it's the whole idea of the S&OP. Yeah, probably it's all a model, and maybe in 3 or 4 days we will order less of this SKU, more of this one, etc. It's not about the exact SKU or exact order. We will do the most effective it is to cover the demand, right? But the problem is that we see that this trend, it's actually overlapping. And this information, S&OP, is for the managers, not for the guy that you just, doing daily work on the work incentive. Why? Because doesn't matter how well you plan, you just cannot physically build more than your operation has. Maybe you should add another shift, right? But the other question appears, where is the good time to do it? Maybe this growth is done for some commercial. Maybe we could, like postpone this commercial for next month. For example, instead of 10 months, like make it 11 to decrease the load here and increase the load here by at the same time adding the second shift. So we will have 5-6 months one shift, and then we could get ready for the demand by adding another shift, etc. So a lot of different decisions, right? But it gives you the overall view that, I mean, on the management level, I'm not really interested in which SKU on which order they are building it here, right? At least that I know they have resources, they have raw materials, they have time, and they have capacity to build it and to do it effectively. And the buffers will not allow them to build excess inventories. But the trick is, my job is to create the environment for the people so they could do their job right. And that's the whole idea of this S&OP, is to talk really briefly. So how the integration with the software could look like. So basically we need just, basic information, SKUs, inventory levels, your bill of materials, your VIP working process, right? Your supply, client orders. So all this information goes to Intuiflow, and the system basically makes all that I was showing you. It automatically purchases materials, build a production plan, and transfer orders to distribution. So it could manage not one even distribution, it could manage one plant and that feeding another plant, that feeding multi-layer distribution network, that feeding the retail shops. So basically the whole system is multi-echelon, multi-levels that could manage the whole supply chains, even for big multinational companies. It actually are using this. It's very easy integration with any of the most popular supply, ERP systems that are on the market. And how the projects looks like, guys. So the first one is the project plan. So we need to understand what is the scope, what we're gonna do, what is the KPIs, what could be the results you want to achieve, and how the current design supply chain looks like. The second is the workshop. It's very good to model your current, just supply chain, to understand what are the workflows, how it works, and understand how we could, what could be the results. And again, the knowledge transfer. It's not only about pressing few buttons, right? Obviously, for the most people working in the system that could work in the system, it's very easy for them. Actually, most of the companies even making this whole management process for managing the materials totally automated. But we need really smart and intelligent people to create and build the operations and tactical models of the company, to create these digital twins that could actually reflect what is happening in the company. Not only allow planning and strategy, but also the execution and the management of the orders to assure the reliability and effectiveness of the system. The next one, rehearsal and just first order management. And that point, we really do validate, people's spreadsheets, all their ERP system. We just wanna see what are the differences, what the outliers. And when we're reaching the point that every single order is in the system, it's always much better than it was before, right? So it's very easy and good, to understand what causing the outliers. Maybe there is some other limitations, etc., that was not discussed before, and this is very good to catch and to adjust to the current company layout. Again, go live, we are making orders together. So this is hyper care and hyper support. So we work like shoulder to shoulder on the one laptop, ensuring that everything goes as smooth as possible. And the fine tuning, we just know how the system is live working. Could be with the people or totally automated, but we want to get our KPIs, right? We want to get the case studies. The whole idea is about the case study. But this slide is from my friends from demand-driven technologies. I really like the idea that Eric spoke about, that software Intuiflow is inspired by innovation. This is the view from the, how they know, astronauts from inside the rocket from the old days. Could you see all the numbers, all the complexity, and just endless buttons? If something goes wrong, you need to know how to push, press, and etc. It could take you years and years of study to be managing this simple rocket that basically could go one way on the orbit and then fell down, and still endless numbers of buttons. But now people, with some basic training, can go with the SpaceX, right, and become the space tourists with little or no education. But it doesn't mean that it is very easy, right? Now it's even more complex, because the rocket not only just fly and explodes, right? It's came back, it's landed up, so it's more like a plane. It's more complicated. So the whole complexity is inside the engine, it's inside the methodology in the system. But people should be very easy to manage and be happy and confident and very convenient at working with the system. At the same time, deliver much higher result that this could be achieved with this old and complex technology. What result I'm talking about? So guys, if you go at the Demand-Driven Institute, you will see a website, a lot of different results. So this is results only our own project experience, company IBM Cloud, and demand-driven technologies. So we just take an average from our case studies. You can look your company from your industry, what was the actual results. And if you're not finding yourself, you just see the averages from the bottom. But again, if you see about how we could decrease inventories, remember I was showing you that we was not shrinking the red zones, right? We was just changing only the layouts. This number of tools that are in the software. I just show you one, the simple one, that this number is very, very easy to reach. And most of the companies, we get much more actually. And we know how the lead time is being reduced. Imagine working with the old school, traditional industries that you say to your clients, hey, you want me something to deliver you, make an order today, I will send you it next month or by the end of like 25 of this month, and you will receive at the end of the next one. This is like more traditional between the companies, right? But why it's happening? Company thinks that they're trying to be ineffective. They're trying to build only what a client actually is ordering, trying to make everything make to order, and it's sometimes good, sometimes not. You need to discover this. But at the end point, some orders are very repeatedly. You can manage this by changing your distribution layout. And imagine that you have a few suppliers, and one say, if you make the order, you need to wait 2 months, and if you order from me, you need to wait 7 days, and I deliver you the order. And actually, all of the materials nowadays, because of the proliferation of technology, are more or less the same level of quality. Difference mainly is at the price. Maybe I can even be a little bit more costly, but you say, hey, 7 days is better than 2 months, right? So I can get even extra margin, and I can get more happy clients that my competitors is delivering for 2 months. So sometimes this could be shrunk by like 80%. So it's really underestimated in the like old school traditional way. Guys, so if you have any questions, I'm just want to ramp up and look at the chat and answer your questions. But guys, this QR code, if you want to get some details about how the DDMRP works, maybe you have some questions at the webinar. But the main idea, if you actually want to try, what could the benefits be for your company? We could make a model together just in a spreadsheet, just simple model. Let's say, hey, we'll took the data, for example, last year, right? And we'll model the supply chain and say, look, so this how you was working last year, right? The fact. And this how we could manage the supply chain with the DDMRP methodology. And we should compare the results. Maybe this is here he was managing better, here the DDMRP is better. What is the total difference? And we could get quite good estimate. For example, we could decrease inventory levels like by 30%, get a higher service level, etc., etc. So you could get real quantified results and quite good idea. Does it worth it, right? Because it takes time, to study the methodology, etc. So was it worth it, right? So I think this is the easiest way to start doing this with the person, with me, or the people from my team. We've been doing this 4 years with the various companies, various industries. So we know, where could be some tricks or the additional opportunities to really make the, good results and to reach those low-hanging fruits to basically give you the best possible result, guys. Yep. So no question. Very good. So you probably understand everything, or almost everything. Yeah. Thank you, guys. Just if you have some questions, you can ask. Yeah. Yeah. Thank you. Okay, guys. I will stop the screen share, and thank you everyone. Yeah, for coming.
Yeah, thanks for all attendees for your time. If you are interested in presentation of whole software and discussing your case, we are ready to arrange meetings and talk about it. Notice us in the chat if you want.
Yep.
Or you can email us later. Thanks to everyone. Have a nice day or evening.
Yeah. Thanks. Bye, guys.
Bye.
Nice.